Okay, it says we're recording. So today we're going to talk. Oh, before we get into here, well, I will tell you this. Today we're going to be talking about geometric sequences, and maybe I should tell you what I'm going to do. I'm going to give you a schedule for the rest of the semester. Let me make this big. Let's talk about the schedule. Okay, so today we're going to cover 8.3. Tomorrow we're going to come 8.46, excuse me, we're jumping up to 8.6, which is the binomial expansion. I spelled that wrong, but that's close enough. Wednesday is going to be the review day. Thursday is going to be the test. Next week, we're going to do is going to be review every day. So I will try to give you, well, and we'll also, so on Monday, a week from today, we'll go over the tests that you took on this coming Thursday. And then I think, so I got an email from the math department. They do have a study guide that that I will post. I will probably post it on, I might post it a little before Thursday, but around Thursday. But the idea is you can do it over the weekend. And then, so on Monday, when we come back, we'll go over the tests, and then you can say, oh, I don't know how to do this review problem or whatever. So as far as reviews, so we'll have that. I will also mention that we've got the previous reviews for all the tests. That's going to be a good review. And then I probably will throw in a Salt Lake Community College final just for fun on a couple of those days. So I'll probably have you take those outside of class, and then inside of class we can talk about them. So next week, we're not going to have any daily quizzes. Your quiz will be to come to class next week. And so it does tell me who's here. Please put your first and last name so that I don't give it to the wrong person, especially if your name is Caitlin or Nathan. Those are the popular names, it seems like. So the final exam is 2 weeks from today. 2 weeks from today. So under the normal schedule, so that's the 27th, April 27th. Now, normally it's from 11 a.m. to 1 p.m. So what I'm going to do, just like I did with the last test, if you take it between those hours and you upload it by 1 p.m., I will give you 5% extra credit. I will have the test open all day long. You can have it open, you can take it anytime you want on that day. But since that's the day that the college had us, so 11 a.m. is actually an hour earlier than our regular class. But that will be the day that I will have it open, and then, but you can take it anytime you want, and you just won't get the 5% extra credit. So does anybody have any questions on the schedule?
So for that final exam, if you start early but end within that time frame, you get the extra credit, right? Or do you have to start at that time and end?
Well, you have a 2-hour time limit. Like if you wanted to come at 10:30 or something?
Yeah.
I guess I don't have a problem with that.
Okay. And then if you
I would, yeah.
And if you start in the time but you like end at 1:30.
So if you're a half hour late, yeah, then you wouldn't get it.
Okay.
So if you want to be a half hour early, that's fine. If you're a half hour late, sorry.
Okay.
So, any other questions? Okay. All right, so we're going to talk about geometric series or sequences today. And Let me grab my book here really quick. And so with the geometric series, so A will represent your first term, and R represents the common ratio. Okay. So the basic formula that you're going to want to know is going to be A sub n. I'll use a capital A because I can't do subscripts. A sub n equals A times R to the n minus 1 power. Now, I will tell you this because I didn't realize here sometimes order of operations matter. So don't multiply the A and the R together. Do the R to the exponent because that should be done first before you multiply it by the A. So remember your order of operations. Okay?
Yeah.
So I didn't think I needed to say that in my first class, but apparently I did. And I learned that as we went through a few. So let's do an example. Let's say that A equals 3 and R equals 2. And let's say that I want you to find the first, we'll just go with 4 terms. So A sub 1, let's pick on, we're going to start at the bottom of the list. Riley, you get to be the first one today. So using this formula here, okay, I want you to tell me what A sub 1 would equal.
So is it 3 times 2n minus 2?
2, and then the exponent is going to be 1 minus 1, right?
Yeah.
Okay. 1 minus 1 is 0, so 2 to the 0 power is
1.
1 times 3?
3.
3. Okay, so A sub 2, let's have Michael, can you help me do A sub 2?
Sure thing. So A sub 2 is 3 times 2 to the power of 2 minus 1. So 2 to the power of 1. So 2 times 3
is
6.
6. Perfect. Okay. A sub 3, let's pick on Lauren, can you help me do A sub 3?
Yeah, so it would be 3 times 2 to the third minus 1, which would be 2 squared. So 4 times 3 is 12.
Perfect. And I hope nothing broke there. A sub 4 equals, whose turn is it now? It is Landon's turn.
It's going to be 3 times 2 to the power of 4 minus 1.
4 minus 1. Perfect. Okay. Do you have a nice UVU shirt on today? I think you do. Yeah,
Yeah,
nice.
buddy.
What about your hat? Your hat's too high. I can't see it. Rise and what?
Rise and grind. It was from my mission. There was a buddy that had a
Oh.
workout program.
Oh, okay. It's a lot better than Rise and Shout. I'm glad to hear that. So, all right. Okay, so 2 to the third power is?
I can't believe
2
I'm
times
spacing,
2
sorry.
is 2 times 2 is
4,
times 2,
8.
8. So 2 to the cubed is 8. 8 times 3 is
8 times 3 is 24.
24. Rise and math. Okay. Perfect. Okay, so let's do one that's a little bit harder. What if I said I want you to find, maybe I'll make this a little bit bigger. I forgot to do that. Okay, so what if I said that I've got a sequence 5, 15, 45, 135, etc. And so I told you it's a geometric sequence. I want you to find R, find A, and find A sub 8. So let's see here. After Landon, it must be Joey's turn. Joey, can you help me find any of those? Did Joey step away or turn himself on mute? Joey's definitely on mute. Okay, we'll move on to Hallie then. Joey, hopefully you're getting this. Hallie, can you find any of these?
Yeah. So is A is going to equal 5, right? Because that's the first
That's
term.
the first term. Perfect.
So
Okay.
finding A of 8.
Say that again.
Should we start by finding A of 8?
No, let's find R first.
Okay, so
What is the relationship between each of those terms?
they all get multiplied by 3.
Perfect. So R is 3. Okay. And so can you find A sub 8?
Yeah. So A sub 8 is going to be 5 times 3. And then is it going to be 8 minus 1 to the 8 minus 1?
Yep, playing more Jeopardy. All right, so that's exactly right. And when I press enter, because I'm using Excel, it's going to give us the answer. Oh, no, it won't because I didn't put an equals in there. Tell you what, I'm going to leave that there anyway. I'm going to copy it, and then I'm going to put an equals over here. And that equals 10,935. Okay, so well done. All right, let's see here. Now let's do one that's even better. What if I told you that the third term of geometric sequence is 63 divided by 4? And I told you that the sixth term of geometric sequence is 1701 divided by 32. And then I said, find the fifth term. Okay. Now, because these are geometric, and because this is probably my favorite formula of this section, at least up to now, one way I could write this is so A sub 3 equals, I'm going to write it this way, 63 divided by 4. I'll make that a fraction. Did I underline it? Come on, underline, I say. Okay, and then I've got A sub 6. A sub 6 equals 1701 divided by 32. And I will underline that so it looks like a fraction. Now, what we can do is we can plug in this formula here, and we can say, okay, well, A sub 3 basically equals A, which I still don't know what A is, times R, don't know what that is yet either, to the n minus 1, so that's going to be 3 minus 1 is going to be second power, or maybe I already it was 3 minus 1, but that's the second power. Okay, so I'm going to do the same thing down here, but instead I'm going to do the 6, so it's going to be 6 minus 1, which is going to be the fifth power. Okay. All right, now the cool thing is that if I divide this one by this one, the A's are going to cancel, right? And I'm going to have R squared divided by R to the fifth. Okay, so I know that R squared divided by R to the fifth equals we can divide these as well. Okay, now when we're dividing fractions here, I'm going to just copy this and I'm going to paste it there. Here, and then well, here, I'll do this. Paste that here. So I've got those two, and then those are, maybe if I draw a big thick line like that. Okay, so I've got two fractions there, okay? Now this is 1 over r cubed. Now what I can do is I can say, well, this is the same thing. So this is 1 divided by r cubed equals, oh, here, come over here. 1 divided by r cubed equals 63 over 4. And then I'm going to multiply by the reciprocal, which is going to be 32 over 1701.
Where did you get the 1 divided by r cubed again?
R squared over r to the 5th.
Okay.
Yeah. Okay. So now I can also flip all of these around. Now you guys know that 4 goes into 32 an even number of times. So what I'm going to do is I'm going to take the reciprocal of everything I've got here so that I've got r cubed on top. So if I've got r cubed on top, so I'm going to put, well, instead of putting the 4 there, I'm going to put a 1 because a 1 goes in, or 4 goes in 32 8 times. The 63 is still going to be there. The 32 is going to be on the bottom, but it's going to be an 8 this time, and the 1701 is going to be on the top. Okay? So are you following me so far? Everybody following me?
Are the fractions all times together? Is that what you just did?
So yeah, we're going to multiply these two fractions together. That's correct.
But not the 1 over r to the 3rd? Is it set equal to that?
Yeah, so this equals that, these two fractions. Okay? So all I did was because I wanted the r cubed on top, I did the reciprocal of everything. And while I did the reciprocal, I also did the 4 times 8 is 32. So that's why I got a 1 here and an 8 here. So are you with me, Hallie? Does that make sense?
Yeah, so when you were multiplying 63 over 4 times 32 over 1701, you reduced fractions, so now it's 1 over 63, 17, or 1 over 8.
Right, and I have a feeling that 1701 is going to divide evenly by 63, and I'm going to check that right now, and it goes in 27 times. Okay, so essentially what becomes then is r cubed becomes 27 divided by 8. Does that make sense? Oh, what happened? 27, I say, divided by, oh my gosh, my unlock's screwed up. 27 divided by 8. Does that make sense how I reduce this fraction here to 27 over 8?
Yeah, you just did 1701 divided by 63.
Right, it goes in 27 times. Okay, now I need to take the cube root. So r equals, the cube root of 27 is 3. 3 times 3 times 3 is 27. The cube root of 8 is 2. 2 times 2 times 2 is 8. And so my ratio is 3/2. So that's important information. Okay, so I found my ratio. Now I can go back to this equation here and I can plug in my r. Okay, so I'm going to copy this and I'm going to paste it over here. Okay, so now this r is a 3/2. Okay, 3/2 squared, which is 9/4.
Are you setting 63 over 4 equal to 8 times?
Yes.
Okay.
Like that. Okay. So you can see that this on the right side is really 9/4 times a. 9/4 times a. Do you see that? Oh my gosh, my thing's not working today very well.
So we still don't know our a, right?
We still don't know our a, but we're going to find it out in just a minute.
Okay.
And so if I multiply by 4 over 9, then those will cancel, right? And that means I also, on the other side, have to multiply by 4 over 9. So my 4's are going to cancel, and I'm going to get 63 divided by 9 is 7. So 7 equals A. Okay, so now I know my A. My A is 7. My R is 3/2. And now I can use this formula again. And I can use this formula to figure out what A sub 5 is right here. Find the fifth term. So A sub 5 is, now I'm going to let Andrew, who hates to rise and shout, can you give me A sub 5?
I was about to start singing the song. You almost caught me there. So it would be the A sub 5 is going to equal 7 times 3/2 to the
Raised
power
to
of
the
5 minus 1.
5 minus 1. Okay. And so, because that's probably going to be a big number, I'm just going to let Excel tell me what that is, or you can plug it in your calculator. And, oh, actually, no, I don't want to do that. I changed my mind. So 3 times 3 is 9. 9 times 9 is 81 times 7 divided by 2 to the 4th power is 16. So equals 81 times 7 divided by 16. And so that is the answer that I would look for on the test. Of course, that's a fraction. So A sub 5 equals 567 over 16. Okay. So I will say that on a test, if you're doing these, I know you could leave it as a decimal, but I would rather you just left it as a fraction like this. The decimal would be 35.4375. But this would definitely be my preferred answer here. And put that in orange. Okay, does that make sense?
Wait, sorry, I'm just trying to catch up with what you did. So A sub 5 equals 7 times 3/2 to the 4th. So that equals A sub 5 equals 81 times 7.
Yeah, so 3 to the 4th power is 81.
Right.
And then I multiplied it by the 7, which was out front.
And where's the 16 coming from? Oh, 2
So the
to
2 to the 4th power is 16, right?
Oh, you're taking 7 times 3 to the 4th all over 16?
No. Maybe I should rewrite this. Okay, so let me rewrite it this way. Okay, so the 7 is still there, right?
Right.
And then I've got 3/2. Get rid of the 7 now.
3/2 to the 4th power.
3/2 to the 4th power. So 3 to the 4th power is 81. 2 to the 4th power is 16. Now I just need to multiply that 81 times this 7, which is out front. That's why I have 81 times 7, which is 567.
Oh, I see. Divided by 16. Okay.
Right. Okay.
Where did we get the 9 over 4? Sorry, it's kind of far back, but I just didn't follow that.
Okay, so if you simplify 3 minus 1, that's 2. So 3 squared is 9, 2 squared is 4.
Oh, okay.
Okay, any other questions? All right, so this is our geometric. Now we're going to do partial sums for geometric. Okay, now what I do want to mention is, just like with the arithmetic sums, we have 2 formulas. Oh, that just erased everything I wrote there. Geometric sums, partial sums. Okay, so I've got 2 formulas. I'm going to tell you how to use them. So if the absolute value of r is less than 1, then you can say the sum, S sub n, equals a divided by 1 minus r. And so this is a fraction. Okay, now this, what we can say is this converges. Now, I'm trying to decide. I might just teach you. I think we're going to stick with this one here for a minute. I'm going to show that 0.9999999, which goes on forever, equals 1. Do you guys believe that? Okay. So here's what I'm going to say. I'm going to write this as a series. So 9/10 plus 9 100ths plus 9 1,000ths plus 9 10,000ths, okay, etc. Okay. These are all fractions here, okay? So if I were to write 0.99999 as a sequence, as a geometric sequence, what is your A and what is your R? So Riley, I think we get to start with you again since there's not very many people here. But aren't you excited you're going to get an extra credit point for being here today? Are you here, Riley? Are you on mute? Oh, no, you're here. Can you hear me?
Yeah.
Okay. So if this is my geometric series, geometric series that represents the 0.99999, where we're adding them all together, what is the first number in the sequence?
Is it just 9/10?
9/10. What's your ratio? Oops, I forgot about that. 9/10, I say. What's your common ratio?
I'm not sure.
Okay, so how do you get from 9/10 to 9 100ths?
Multiply by 10.
Multiply by 1/10, right?
Oh, yeah.
Your common ratio is 1/10. Okay, so the absolute value of your ratio, this number here, is less than 1, right? Okay, so what this means is it's going to converge to a number, and I'm telling you that number that it converges to is 1. Okay, so if we plug it in this formula here, the first term is 9/10. Do it this way, 9/10. And then on the denominator, I'm going to go 1 minus 1/10. Well, what's 1 minus 1/10? Oh, you stupid. 1 minus 1/10. 1 minus 1/10. I didn't think that was a tough question, was it?
9/10.
9/10, thank you. So I'm going to get 9/10 divided by 9/10, and that equals 1. Okay, so I've just showed if you just keep adding these together, 0.99999 really does equal 1 if you go on for infinity times. Okay, kind of cool. You kind of all knew that, but okay. So that's one formula. Now, the formula that you're going to want to use if the absolute value of r is greater than 1 is probably going to be this formula here. So S sub n equals a times 1 minus r to the nth power divided by 1 minus r.
Are you saying S of n equals a times 1 minus r to the n?
Yes. And just so you know, it's a little hard for me to format with this, but, and that's a fraction, okay? So this is your other formula that you're going to want to remember, okay? And this is what we would say it diverges. Okay, so it's going to get, so basically diverges means it's going to get bigger and bigger and bigger. Like you'll never, like on the first one, it converged to the value of 1. You're going to, if you keep adding, you're just going to get closer and closer to 1. In this case, it's going to get larger and larger. It doesn't converge to a single number. And so that's what diverges means, okay? So let's do an example here. If I had a geometric sequence that was 1 plus 4 plus 16 plus as many terms as I need until I get to 4096, okay? And I told you to find the sum, okay? So you're probably going to use this second formula here because R, well, you can figure out what is your R. What is your R? Let's ask Michael, what's your R in this case?
4.
4. And in this case, your A is going to be
1.
1. Perfect. Okay. So now we can use this formula here, but the problem is I don't know what my N is. So how do I figure out what term 4096 is?
Wait, sorry, really quick.
Mhm.
How do we know which formula to use, the first or the second?
So look here, the absolute value of R, if it's greater than 1, you're always going to use this one.
Oh, gotcha.
Actually, let me back up a second. If R is less than 1, so let's go back to this example that we used in this case here, where we had R as 1/10, okay? What you're going to find is this formula becomes this formula, okay? So even, I guess the safer formula, this one works all the time, no matter what.
Mm-hmm.
But so if you think about this, if R is 1/10, if I take 1/10 and I raise it to, say, the 1000th power, but even before I press enter, you should tell me that that's very close to what?
One.
No, it's not. 1/10 to the 1000th power.
Oh,
Oops. It's going to be very close to
0.
0. Okay. And in fact, it's so close to 0 that Excel calls it 0. Okay. And so essentially, you can see that this R the nth power just drops out. And then you just have A times 1, which is A. And so I guess the safer formula, if you're not sure, you can always use this one, because if n gets really large, that R to the nth power becomes 0.
Okay.
If your R, but your R has to be less than 1. If your R is greater than 1, like it is in this example here, okay, we're just going to plug it into this formula. Okay, so now the only problem is we need to figure out what is my N. And so how would you figure out what is your N for 4096?
4096 minus 1? Or wait.
Yeah, you don't know. So 4096 is A sub something. We don't know what the N is. So how would you figure out what the N is?
Well, then
Michael, can you save me? Any ideas?
So would you take 2 of the numbers, make 2 equations, and cancel out everything except the ends?
Oh, that's even harder. You can find an easier way. The easier way is to remember this formula that you've already forgotten that we learned earlier today. So we know that that formula works for anything, right? So the first term is going to be a, which in this case is 1, times r, which in this case is 4, raised to the n minus 1 power. We know in this case it equals 4,096. Okay. And so probably the easiest way to do this is just to say, well, I don't know, what's 4 raised to the 5th power? Whoops. The 5th power is 1024. For the 6th power, 4,096. So n minus 1 has to equal 6. N minus 1 has to equal 6. So therefore n has to equal 7, right? So in that case, sorry, n equals 7. N equals 7. So we know that this is the 7th term. 4,096 is the 7th term. So now we can plug it into this formula here. A is 1 times 1 minus your ratio, which is 4, raised to the 7th power, divided by 1 minus 7. I forgot my parenthesis here. Okay. So in this case, 1 minus 4 to the 7th power is negative 16,383, and 1 minus 7 is negative 5. And so now if I just take the numerator divided by the denominator, I get 3,276. Oh, except for I forgot something. The thing that I forgot was I need to multiply that by the first term. Oh, the first term is 1. No, I guess I did get that right. Never mind. It was correct. Why am I getting something wrong? The negatives cancel.
Shouldn't the bottom number be 1 minus r?
Oh, it's a 4, not a 7. That's what I did wrong. There we go. And so then it's 3. There we go. And now it's negative 3. There we go, 5461. Okay. All right, now the last one that I want to do really quickly, just because I want you to get used to the summation notation, is what if I said I want to find the sum of from k equals 1 to oh, I lost my thing here. K equals 1 to 6 of 7 times negative 2/3. That's a 3. It's a terrible looking 3. I'm sorry. Maybe I can. To the k minus 1 power.
Is that
Okay.
a negative 2/3?
Negative 2/3, that's correct. Okay. So the question is, which of those two formulas should I, well, I guess I should use the second formula, because in this case, we're assuming that n goes to infinity. So we're going to use the second formula here, okay? So S sub n is going to equal A. So if k is 1, the first term, 1 minus 1 is 0. So negative 2/3 of the 0 power is 1. So A sub 1 equals 7 in this case. And then we're going to do this for the first 6 terms. Here, I'm going to copy this formula so we can see it. Okay, so there's our formula here. And so we're going to get 7 times 1 minus, well, your ratio is going to be negative 2/3 to the 6th power all over 1 minus negative 2/3. Okay, so that's going to be 1 plus 2/3, which is 5/3 in the denominator. And then 1 minus 2/3 to the 6th power is, works out to be 61 minus 64 over 729. And now we can just do some basic math, and that equals 931 over 243 if we get our common denominators right. Okay. So if you plug that in your calculator, you should get 3.83. So that also works there. Okay. So do you guys have any questions for me? Okay. Well, the quiz is posted, and quiz tomorrow will be on 8.3. I'm going to give y'all an extra credit point today on today's quiz. And so you'll see that, and we'll see y'all tomorrow.
Thank you.
Thank
Have a good one.
Thank you.
You're welcome.